Hello, this is Anthony Radamonte with Copley Controls. Today I'll be going over the hardware triggered output features available on plus drives. Um, so this is a hardware position triggered output. And then we also have software position triggered outputs as well. Software position triggered outputs are pretty much the exact same thing, except they're just a little bit slower in the reaction time. So the software will trigger the output rather than the hardware. The hardware, when I say hardware triggered, that means that the firmware at the firmware level is reacting to the encoder, the raw encoder signal. So here I have a CVM program here I've used to configure output 1 to be dual direction compare mode. That means that if I cross the position in either direction, I'll trigger the output. And then I set value 0 equal to value 1. What that essentially does is I don't care about anything other than this one value of 100,000, and I'm going to trigger in either direction at that position. So if I cross it in either direction, I'll trigger it. But if I trigger it to say, let's say 200,000, and I run the example, and I record, and I cross, I'll see that you will trigger at either 100,000 or 200,000 in either direction. So that's how that would work. This is, of course, with increment equal to 0. If you want to use an increment in mode 0, which is the dual direction compare mode, what you have to do is you have to make sure that your motor is in between these two positions, right? Because we're going to be incrementing either value 0 or value 1 by this increment value. So the increment value has to be double the difference between value 0 and value 1. So those two things have to be met. You have to be in between these positions, and the increment must be double the difference of those positions. So right now I'm sitting at about 300,000, so I'm going to change this to be value 0 will be 300,000. That's 300,000. And then I will change value 1 to be 400,000. And then I'll change the increment to be 200,000. Okay, and I'm using a pulse. I'm not toggling the output. I'm going to pulse for 2 million nanoseconds, which is just about 2.9 milliseconds. So this can go as low as 10 nanoseconds, but we wouldn't see it on the scope. Okay, let me save this and run it. And now, yeah. So let's hit the record button here. So yeah, as you can see there, it's going to increment every. It's going to increment the value, the value 0 and value 1, and it'll trigger in either direction. So let me go the other way too, go in the negative direction. I'm using an absolute encoder, by the way, Tamagawa. So yeah, and going in the negative direction, you get that nice triggering every 100,000. So this increment value is applied to value 0 when we cross the 400,000 threshold, and then again it'll be applied to the 400,000 threshold when we cross the 500,000 threshold. So that's how that increment works. Yeah, now these other modes are set output in position window, single direction compare, which is basically it's the same as it's this exact same thing you see here, except that we don't look at going in the other direction. So you can either go in the positive direction or the negative direction. And then you will have a single compare with an end position. So you can go in one direction with an end position. Yeah, so that's how the hardware triggering works. If you want to read up on these features more, then you can go to cobleycontrols.com, go to support, general resources, app notes, and then you go to setting outputs at position, app note 137, and we talk at length that the difference between software and hardware triggered, and both are triggered, are setting outputs at position. So let's just go to the hardware section because that's what I'm talking about here. The hardware triggered outputs, starting with this firmware 1.40, it's available on plus drives, yeah. So this is what that Java bean does. It sets the output config parameter to 16, and then it's going to set all these other parameters, scan open objects, to invert the bit, enable the module, if you want to invert the state of the output, then selecting the mode of the compare module, yeah, so here's the modes, the different modes that we were talking about, where you can do dual compare, single compare mode, set it in a position window, a single direction compare with an end position. Yeah, so you can do this. You can set this output up in CMO as well, or CML, just using SDOs. And I've done that here. I have just a simple hardware configure hardware position triggered output function, and this is set up to configure output 1 to be mode 2, which is fire in the position window. So here we're setting OX70 to 16, and then we're going to be setting bits 0 and 4 of object index 2160. So it's going to enable the module, set in the position, and it's going to select mode 2. And yeah, we're setting the limits. And yeah, so here's also if you wanted to use the compare increment or the time delay. And then also CMO, I wrote a code. This will be a standard CMO example. I wrote a code that'll pass the serial binary data to object index 2000. So what this does is it'll configure the software position triggered outputs. So if we go back to that app note, say you don't have a plus drive, but you still want to do this position triggered functionality, you would just, you can use the ASCII command line, or you can use our CVM to do it. But you'd send this command for, say you wanted to set a software position triggered output in this position window. You would set it to mode 4, and then you'd set the 2 positions. And that's what I did in CMO. I'm setting this to 4, this parameter 70, right? And then I'm sending the rest of the parameters, the positions, byte swapped. So yeah, hopefully this helps for programmers and CMO if they want to configure an output in their program. So yeah, that's how you would use the hardware position triggered output. Yeah, hope this was helpful.